Hello everyone, I am Dr. Godandaraman. In this section we are going to discuss with Fourier series problem, the interval 0, 2 pi. See the problem, express f of x equal to pi minus x whole square as a Fourier series of period 2 pi in the interval 0 less than x less than 2 pi. Hence deduce the sum of the series 1 plus 1 by 2 square plus 1 by 3 square plus 1 by 4 square plus and so on. First of all, the Fourier series when the interval 0, 2 pi, the series expansion is nothing but f of x a naught by 2 summation n from 1 to infinity a n cos n x plus summation n from 1 to infinity b n sin n x. To find the coefficient value a naught, a n, b n using Euler formula, so a naught is nothing but 1 by pi 0 to 2 pi because the interval 0, 2 pi f of x dx, and a n 1 by pi 0 to 2 pi f of x cos nx dx, cos nx dx, and then bn 1 by pi 0 to 2 pi f of x sin nx dx. Now to find the value a naught, a n, b n, the function of x given pi minus x whole square. So therefore a naught is nothing but 1 by pi 0 to 2 pi f of x dx. Now the f of x value pi minus x whole square into dx. So now to solve this two way, one is to expand this pi minus whole square equal to a minus b whole square form, a square plus b square minus 2ab. Therefore this is a pi square plus x square minus 2 pi x. This is a one way to solve. So or another way, integration of a minus x whole square, this is nothing but a minus x power 3 by minus 3 because of minus x coefficient minus, therefore minus 3. So solve this way or this way, and general integration x power n dx is x power n plus 1 by n plus 1. So therefore now 1 by pi, now I expand this 0 to 2 pi pi square plus x square minus 2 pi x into dx. Now integration of pi square into dx. So pi square constant, dx integration x plus x square dx integration x cube by 3 minus 2 pi constant x integration x dx integration x square by 2. The limit 0 to 2 pi. So now substitute upper limit and then lower limit. 1 by pi pi square, substitute upper limit where x plus 2 pi q by 3 minus 2, I think 2 will be cancelled. So therefore pi 2x square, this is a upper limit, minus lower limit 0 into any term 0 plus 0 cube 0 minus 0, upper limit minus of the lower limit, this is 1 by pi. So 2 pi cube plus 2 cube 8 pi cube by 3, then minus pi, this is a 4, this is a 4 pi square, 4 because 2 pi whole square, 2 square 4 pi square. Now simplify this, the simplification is nothing but 1 by pi and 2 pi cube, and this is a minus 4 pi cube, 8 pi cube by 3 minus 2 pi cube. When I am taking this LCM 6, so 1 by pi into 2 pi cube by 3, this pi will be cancelled. So therefore 2 pi square by 3 a naught. This is a naught. And then find a n. So a n is nothing but 1 by pi 0 to 2 pi f of x cos nx dx. So now 1 by pi 0 to 2 pi pi minus x whole square cos nx into dx. Now to consider, so this is a u and this is a v. So the Bernoulli function integral uv dx equal to u v1 minus u dash v2 plus u double dash v3 and so on. So this is a Bernoulli function. So now consider here u. So this u dash, u double dash, this is a differentiation, and v1 v2 integration. So therefore for here u, I am taking u equal to pi minus x whole square, u equal to pi minus x square, and then v equal to cos nx. So this is a differentiation, and this is a integration. So therefore when I differentiate u dash x power n, so d by dx of x power n is nothing but n into x power n minus 1, okay, and d by dx a minus x whole square, differentiation 2 into a minus x into the variable differentiation constant 0 minus 1. So this is a differentiation. So therefore 2 pi minus x into minus 1, and then when again differentiation is a minus 2 into minus 1 minus 2 pi minus x, when I differentiate it's a minus 1, u triple dash is 0. Now v1 integration cos nx integration of cos ax dx equal to sin ax by a, integration of sin ax dx equal to minus cos ax by a. For here cos nx integration sin nx by n, then v2 minus cos nx by n, already one n is there, so n square, and then v3 minus sin nx by n cube. So now the form is nothing but formula u v1 u dash v2 u double dash v3 and so on. So u triple dash 0, so just stop up to this form. Therefore a n is nothing but 1 by pi, the formula u v1. So this is a u and this is a v1, pi minus x square u v1 sin nx by n minus u dash is minus 2 pi minus x u dash and v2 minus cos nx by n square, then plus u double dash minus 2 plus minus 1 2, then minus sin nx by n cube 0 to 2 pi. So now substitute upper limit and then lower limit. For here see sin 2n pi 0, sin n pi 0, sin pi 0. Similarly cos 2n pi 1, cos n pi minus 1 power n, cos pi minus 1, cos 0 1, sin 0 0. So this is a value. For here when I substitute 1 by pi, when I substitute upper limit, so don't substitute and then next step don't proceed, because once you substituted, sometime careless mistake is possible. Because of here I substitute 2 pi, pi minus 2 pi whole square, it's coming with a minus pi whole square is a pi square. So now the sin 2n pi 0, but the whole term 0, but we missed this pi square. Sometimes it's a possible next pi square to continue with the next line. So whenever I am substituting for 2 pi, where you are substituting here 2 pi, therefore this term upper limit 0, then minus of minus plus, plus into minus, minus, when I substitute 2 pi here 2 pi, Therefore, minus pi, when I substitute 2 pi, minus pi, and here when I substitute cos 2n pi, or one line, the first understanding purpose I should write everything, but don't do that. So pi minus 2 pi square sin n 2 pi by n, and then plus minus pi minus 2 pi cos n 2 pi by n square, and then minus 2 sin n 2 pi by n cube. So this is the upper limit, minus of lower limit pi minus 0 square sin 0 by n, then minus minus plus plus minus minus, therefore pi minus 0 cos 0 by n square, then minus 2 sin 0 by n cube. So now this term, I think sin 2n pi 0, cos 2n pi 1, sin 2 pi 0, then sin 0 0, cos 0 1, sin 0 0. So therefore this is a 1 pi, the first term 0, minus minus pi 1 by n square, then minus 0, this is the upper limit, minus of the lower limit, the first term 0, then minus pi by n square, then this term also 0. Therefore 1 by pi, minus into minus plus, so pi by n square plus pi by n square. So 1 by pi into 2 pi by n square, the pi will be cancelled, so an 2 by n square. And next to find bn. So bn is nothing but 1 by pi 0 to 2 pi f of x sin nx dx, then substitute f of x value 1 by pi 0 to 2 pi pi minus x whole square, and then sin nx dx. As usual, same procedure, this is a u and this is a v, and the Bernoulli function integral uv dx u v1 minus u dash v2 plus u double dash v3 and so on. So this is our form. Now the u dash, u double dash, everything is differentiation, and v1 v2 is the integration. Now direct to do that, u v1. So how to do this? 1 by pi u v1. So u as usual to write. This is I am doing direct. Sin nx integration minus cos nx by n. Then formula minus sin u dash. So this term differentiation. So 2 into pi minus x into minus 1. So u dash. Again this term integration minus sin nx by n square. And then plus u double dash. U double dash means 2 into minus 2. This is a minus 2. Then pi minus x differentiation minus 1. Then minus cos. So plus cos nx by n cube. 0 to 2 pi. So when I substitute upper limit, so whenever I am substituting upper limit, this is a pi minus 2 pi whole square. So I think this minus pi square or minus of minus pi minus 2 pi, so pi square, and this is a minus cos 2n pi 1 by n, then minus into minus plus, plus into minus, for this term 0, therefore 0. Then this is a minus into minus plus 2 cos 2n pi 1 by n cube. This is the upper limit, minus of the lower limit. So this is a pi minus 0 square pi square minus 1 by n, because cos 0 1, this whole term sin 0 0, for here plus 2 cos 0 1 by n cube. Then so this is a 1 by pi minus pi square by n plus 2 by n cube. For this is a plus pi square by n, then minus 2 by n cube. So I think to cancel this terms, plus minus, then bn 0. Now substitute a naught, an, bn in the Fourier series expansion. So this is a naught 2 pi square by 3, an 4 by n square, bn 0. Substitute this every value into the Fourier series expansion. F of x a naught by 2, n from 1 to infinity an cos nx plus n from 1 to infinity bn sin nx. So substitute a naught 2 pi square by 3 by 2 plus n from 1 to infinity 4 by n square into cos nx plus bn 0. So now this is a cancel. When I cancel this 2, so pi square by 3 plus, when I am taking constant out, n from 1 to infinity cos nx by n square. So this is a Fourier series expansion. Suppose the question only Fourier series the given interval, then the answer is over. But extra what is mentioned, extra hence deduce the sum of the series 1 by 1 plus 2 square, 1 by 1 3 square and so on, right? Therefore now here 0 to 2 pi. So this f of x nothing but pi minus x whole square. Here 0 is a point of discontinuity because 0 to 2 pi. So but it's an end point. So when here 0 is a point of discontinuity, which is an end point because this is a end point of the interval 0 to 2 pi. So therefore the value of Fourier series, therefore the value of Fourier series when the point x is 0 is equal to the average value of f of x at the end point. This formula already given. So this is a convergence of the series. So therefore the series convergence is nothing but the series converges to f of 0 plus f of 2 pi by 2, the end point taking average. So when I am substituting x 0 where f of x is nothing but pi minus x whole square equal to pi square by 3 and then plus 4 summation n from 1 to infinity cos nx by n square. So here when I substitute x 0, for this is a term pi minus 0 whole square, right? But this series is nothing but this series is converges. Therefore f of 0 plus f of 2 pi. So when I substitute 0 here, what is the term? F of 0 plus f of 2 pi by 2. So when I use the convergence series cos nx by n square. So for this f of 0 is nothing but pi square plus 2 pi minus pi whole square again pi square by 2 because of f of x pi minus x square, f of 0 pi minus 0 square pi square, f of 2 pi pi minus 2 pi square, this is a minus pi whole square equal to pi square. So this is a term. Now pi square by 3 plus 4 n from 1 to infinity cos nx by n square. So when I substitute x 0 for this term cos 0, for here cos 0 value 1, Therefore, this is the 2 pi square by 2. When I am taking this sum left hand side, minus pi square by 3 equal to 4. When I substitute n from 1 to infinity, so 1 by 1 square, 1 by 2 square, 1 by 3 square up to infinity. So for this cancel, when I am taking LCM, 3 pi square minus pi square, so 2 pi square by 3 equal to 2 pi square by 3 equal to 4, 1 by 1 square plus 1 by 2 square plus 1 by 3 square plus up to infinity. So this 4 I am taking to left hand side, so therefore 2 pi square by 3 into 1 by 4. So 1 by 1 square, 1 by 2 square, 1 by 3 square and so on. So when I cancel this 2, therefore this is a pi square by 6. 1 by 2 square, 1 by 3 square up to infinity. Thank you.